Welcome everyone joining on Twitter or YouTube. We will have 5 minutes and then we can get going. If you have questions, I think it's easiest if you jump on Zoom and ask them here, but otherwise we'll be monitoring Twitter comment section as well. If you have questions, then we'll answer them here. So can you stop sharing for a second? I'll give a short intro and then I'll give you back the mic and then I can take it to the screen.
Sure.
At least it's been the tradition so far. We can keep it until the last one. I wonder how many developers are now just scrambling for the last minutes and trying to put everything together to submit for Supernova. So the university vibes are back of the last minute submissions, at least for some teams, I imagine.
You just reminded me how bad it was like before the exams or deadlines to have to turn in all that material and everything like looking good, you know, and you were like doing revisions at midnight. I think it's gonna be like that for a lot of teams.
I think so too. But those few hours are so productive. If every hour of your life is that productive as the last few and when you submit in a university or Supernova in this case, then yeah, then the world would be a better place, or at least would have more stuff and more productive people. But yeah, that's I guess that's impossible to keep up. Only Elon can do it. I think he's that and more productive in every waking hour.
Well, but he also has like the smartest on his side, right?
Sorry?
He also have a lot of smart people that he actually hired.
Yeah. Yes. Oh yeah. I'm not saying he's doing the most of the work. I'm saying he's doing insane hours and still be really productive. Yeah. Shout out to Elon. But yeah, hiring smart people, I think, is one of his maybe main focus, or it should be, or it has been. I guess it was similar with Dom in the beginning of Definity, like hiring the best cryptographers. So we make sure that we can build this thing. So far, so good. We have someone in the audience saying that I've heard some teams going through state loss in the final hours here. Godspeed to them. Yes, and yeah, good luck. I hope the cycle faucet works again, because I heard some teams are having issues with that as well. But I mean, in any case, if you run out of cycles, maybe you can buy a few ICP and just fill that up. Welcome everyone joining. Just a few minutes and we'll begin. Also, this session will be a bit more technical, so I want to leave enough time for Marius to talk. Behave in the Zoom chat, please. You don't want to kick anyone out. But very creative, very creative. Ooh. All right. I mean, I think I warned you, so let's
Oops. I think Andrew fell off 1 second, so we wait for him.
Okay.
Yeah, he is back.
I'm back. This happened a few times, and I think my internet connection knows exactly to cut off at the moment that I would start the workshop. So, but let's do that now. Oh yeah, I have to kick someone out still. You have been warned, and you are continuing to be childish. So, and we have one last person in the audience. Wonderful. Okay. Hello, everyone. I'm Andrew from Dfinity, and welcome to the last workshop, or last Supernova workshop. And we are planning to continue something similar later, but this will be the last time that it is under the name of Supernova. And yeah, today we have Marius Sili, a full stack developer from Kryha, and he's going to talk about NFTs today. We had a few workshops about NFTs, but and today is going to be a very interesting one. We have a little bit of conceptual introduction, and then Marius is going to dive deep into the details and the technical details. So buckle up. I think it's going to be a fun one. And Marius, please take it away.
Yes, sure. Thank you very much, Andrew. Like you said, I'm a full stack developer at Kryha. We are a blockchain company, and today I'm going to talk to you about how to create and sell NFTs on the internet computer. And I am going to use the code we wrote for an application that we call Biling. First of all, who we are. We are Kryha. We're a Web3 venture studio, and we build user-focused applications, decentralized applications, and we also focus on community education right now. Why am I here? To share our insights on how to work with the internet computer and give you the tools needed to build your own dapps on the internet computer. So what are we building? Our goal is to build an NFT marketplace where the NFT owners can put their NFTs up for auction and other users can place bids on them using ICPs. We will follow the English auction model, and the English auction model is described as follows. Basically, there is one seller that wants to sell a specific item. It specifies a starting price, a minimum amount that needs to be added to the previous highest price, a duration, and a buy now price. A potential buyer can place a bid that is higher than the previous one, or immediately buy the item if they specify if they pay the buy now price. When bidding, the user escrows the money to the third party, and the third party refunds the previous highest bidder. And actually, when the seller is creating the auction, it is also escrowing the asset, in our case an NFT, to the third party. But in our case, the third party will be a canister. When the auction ends, that third party gives the money back to the seller and gives the item to the buyer. So which features are we implementing in the applications? Minting and owning NFTs, of course, and transferring them. We are implementing a wallet view so that the user can look at their own NFTs and mint new ones, etc. We want to implement the possibility to create an auction with an NFT you already own. We want to implement the possibility to view your own auctions and to view auctions that are also created by other users as well. And we want to add the possibility to bid on those auctions if, of course, they're still not expired. And yeah, we want to basically handle the whole English auction flow. So here we have a diagram showing the interactions between the canisters. So canisters, as you may know, are, if you're coming from Ethereum, you can basically, on a high level, let's say, while developing an application, you can basically think of them as contracts, and if you're coming from Web 2, you can think of them as microservices. Or client applications in the case of the front end. So the user interacts directly with the front end, and the front end communicates with the internet identity canister in order to authenticate the user. The front end also communicates with the backend canister. The backend canister is the one that handles auctions and bids, and also communicates directly with the NFT canister in order to perform transfers at the end, at the beginning of an auction. But I will show you the whole behavior a bit later in a better flow. NFT canister also communicates with the backend canister. Actually, the backend canister calls the NFT canister, and the backend canister and the front end both call the ledger canister. Why the different colors? Oh, the front end, because it's the client canister and it's written in React. The backend and the NFT canisters are, let's say, implemented by us. Actually, the NFT canister, I took an already existing library from an open source implementation from GitHub, and we modified it to better suit our needs. And this one, we implemented it entirely. And these are already existing on the internet computer. Let's look at how do we store the data on our canisters. So the backend canister will have three important maps: the auction map, the bid map, and the user map. This is so these will contain all the auctions, these will contain all the bids, and these will contain the user data related to these. I will show you another diagram later that will explain it better. On the NFT canister, we have a map with the user data and a map with the token data. And currently, the file data is stored on the canister itself. Then we have this tiny diagram, like explaining on a very high level how the models interact with each other. So an auction is bound to a token. It's a one-on-one relationship, and an auction can have many bids related to it. Since and of course there will only be one higher bid. This data is stored on the backend canister, the auction controller, and this, of course, is stored on the NFT canister.
Can I have a question?
Yes, sure.
With the previous slide. So this means that each bid that comes in should come in synchronously, because if you have two asynchronous bids at the same time and one of them is higher than the other, then it could cause some problems, or how would it work?
Let me think about it. Theoretically, yes, you're right about it. But we haven't gone to that level yet of thinking about it. But
and I guess if one of the requests goes through, that person gets the NFT.
Mm-hmm.
Then the other request, I mean, there would be if there's a slight time delay.
I need to relook at the implementation actually to make this to give you an honest answer on this.
Okay.
We've encountered definitely problems with race conditions, and some of them we've addressed them. and some of them we left them for future, like to work them in, to fix them better in the future. Shall I continue?
Yes, please.
Okay.
Thank you.
So now we're going to look more in deep at the NFT canister, and we're going to look at the actual implementation of it. What does the NFT canister do? First of all, it handles the minting and the transfer of the token and the storage of the data. Basically, this is what it's supposed to do. And as I said, we took an open source library from GitHub and called IC token, and we built upon this one. So first of all, let's have a look at the declaration. So these are the imports. We're just importing a few files. So this is declared as an actor. Why are we declaring it as an actor and not an actor class, even though it could be useful to declare it as an actor class? In our case, we wanted to import it as a canister and to deploy it in the same DFX. So in order to be able to import it as a canister in the other backend, we needed for it to be just an actor and not an actor class. So we declare the actor, and next there are a few types that are being redeclared to be able, so we can use them in the scope. We declare some error variants: unauthorized, token not exist, invalid operator, that are going to be returned in case of a failed transaction. And we are declaring the transaction receipt that has two cases, the OK and the error case. The OK case will carry a transaction ID, and the error case will carry this error defined here, the mint result, which will be returned after a successful mint or unsuccessful, if in case it's an error. In case it's an error, it returns one of those errors, and in case it's a successful transaction, it will return the token ID, the newly minted token ID, and the transaction ID. So next we have these variables. For now, we just set them to these names that describe the token. And this is the owner variable that in the beginning we set it to the 0 address, but later we will call a function that we will set it to the address of the backend canister. And then we have the token entries, which is the array of all tokens we have, and the user entries, which is an array containing all the user information we need. These arrays are stable, so they are persistent, and these are the hash maps. And the hash maps cannot be persistent, of course, and we need the pre-upgrade and the post-upgrade functions in order to first generate the arrays from the hash maps before upgrading the canister, and after upgrading the canister to regenerate the hash maps from the stored arrays. Then let's focus on the init function. I've told you about it. And the init function will be called only once, and it will be called after the deployment, basically. And we will provide in our case, we will provide the principal of the principal representing the backend canister as the owner, because we want the backend canister to be able to interact in a privileged way with the NFT canister. So but we also have a set owner method function that will allow the backend canister to eventually change the owner of this. Next, we have the more interesting functions. We have the mint. This mint was already implemented in the library. We found on GitHub. But the issue with this one is that it can only be called by the owner of the canister. And you also have to specify the principal to whom you want to mint the token. So we re-implemented another method called mint for myself, and where we actually just provide, which can be called by any color, and it will mint this token for that specific color. So if I provide a certain image, I will be the owner of that image. And it contains mint payload. And here, what are we doing is we generate the metadata coming from that payload. And as you can see, we are storing the actual content of the file, the actual asset in the canister. Here we are still continuing to generate the needed objects, and here we are basically updating the hash map with the new token. We are adding the new token to the token's hash map, and here we're doing another call to update the other hash maps, the user hash map. And we increment the total supply, and then we add the transactions to our record. And as said before, we return the token index and the transaction ID. Next, we have the transfer function. And we have another one, which is called transfer to auction. They basically do the same thing, but the difference is that this one requires a principal, while this one does not. And I will explain it later. Let's focus on transfer first. So it requires a principal. So who are we sending this token to? And it requires the token ID. First, we check if we are the owner of the current token. And in case we're not, it gives an error. In case we are, it approves this transaction and executes the whole transfer procedure, basically updating all the hash maps and the data stored inside. And then we, of course, as always, add the transaction to the record, and then we send the ID of the transaction. Then what's the difference with this one? So the difference between these lay here, basically. So here, sorry, in the transfer. The transfer we are transferring to a specified principal, but here we are transferring to the owner, which in our case will be the backend canister. Why do we want this call? Because this way, when creating an auction, we can escrow our token to the auction canister without specifying to the backend canister without specifying its ID. But the procedure is very similar, and yes, besides this part here. Now, so do you have any questions for now?
Not as of now. And actually,
okay.
One just came in, so let me read that out at this moment. Good timing. Putting XMP or sidecar metadata for attached files, JPEGs, etc. aside, what opportunities have you seen for creator metadata within NFT tokens? For example, to allow music artists to insert their individual artist code that facilitates royalty payments?
Mm-hmm. We haven't really looked into this particular case. We've certainly discussed about this, but that is a good question, and it's a good part to explore.
Yeah, that's an answer. Perfect. Let's continue.
Yes, sure. So next we have the backend canister, or let's call it, I will say, and I already said actually, backend, a canister, auction canister. Let's say these are interchangeable in our case, because this is the actual canister, the canister that actually handles auctions and bids, like illustrated before. So yeah, basically it handles creating, activating, and closing an auction, bidding, and retrieving data. And now I'm going to explain what activating and closing an auction in our case means, which is, I assume, the most confusing part. By showing the whole flow. So let's say Bob wants to sell an asset. So first of all, Bob mints an NFT, and the NFT is stored in the NFT canister, and it's currently owned by the creator, because Bob called the mint NFT for myself function described before. So, and then Bob then proceeds in creating an auction with that particular NFT, and the NFT ownership, by doing that, the NFT ownership goes from Bob to the backend canister. So Bob is escrowing the NFT to the backend canister. Next, Bob, but when creating the actual auction, it will be in a pending status. So people still won't be able to. So people won't be able to place bids yet. It's like in an initial status. In order for people to be able to place bids on it, Bob needs to activate the auction by calling a function on the backend canister. We will see it later. Then once it is activated, people can place bids on them. So let's say Michael places a bid. What happens is that the ledger canister transfers ICP tokens from Michael's account to the account of the backend canister. And what happens next, if someone else places a bid, then the ledger canister transfers the ICP tokens from Alice to backend, but it also transfers the ICP from the backend to Michael, in our case, which was the former highest bidder. So the backend, let's say the backend canister is seen as an entity, as an owner of both the asset and the highest bid amount in this case. And once a highest bid comes in, the old one needs to be refunded. And now let's say that the auction expires, or that we've reached the buy now price. Bob can close the auctions, and when Bob closes the auction, the NFT canister will transfer the NFT from the backend to Alice, which is the highest bidder, and the ledger canister will transfer the ICP from the backend to Bob, which was the original owner of the asset. And now let's rewind it. Let's look at it more in detail, how to create an auction. And I will also show you the code this. So first of all, let's start with the canister imports. So we are importing, we are using canister imports to import the NFT and the ledger canisters. And because we want to communicate with them from this, from the backend canister itself. It is useful in our case when, for instance, we want to transfer money from the backend account to the account of the seller. So here is the declaration. As before, it's an octet, not a class, because in this case we don't need it. And here we have the database, the persistent database that contains an array of auctions, an array of bids, and an array of users' data. And here we have the maps that will contain, this is the auction map that contains details related to auctions, the bid maps that contain details related to bids, and users that contains detailed users. And here we have the pre-upgrade function that will basically build, that will use the entries of the current maps to create the arrays, to update the persistent arrays. Okay. And let's continue with how. So let's look at the auction creation flow. What happens is that, like we said, Bob mints an NFT. So what needs to happen? The NFT needs to be stored. And this part we've already covered in the NFT canister. Now, what happens when Bob creates an auction? The ownership needs to go from Bob to the backend canister. And of course, all this data should be created on the backend canister. And also, and then we'll look at how activation works by showing you the activate function. So let's say Bob creates a new auction and provides some auction data. The auction data will contain the following data: the name, description, a starting price, a minimum increment amount, duration in days, a buy now price, and the ID of the NFT related to that auction. So first of all, we check if the user is authenticated. Then we check if the user is the actual owner of the NFT. We then build the auction object, the auction state that has this following data. I'm not going to dive too deep into the types because I don't think I will have time for that, but we do have the tutorial and I will show you later where you can find it. And there I go more in detail into this stuff. Then we update so we define the auction state, and then we update the auction map. And also we check if in the user, here we update the user map. So we check if it exists. If it does, we append the new auction ID to the current to the currently existing ones. And if it doesn't, we just create a new user state, and we put it in the map. So then we increment the auction ID, and we send an OK, a successful response. So now let's and So this gets called by the client, but in the same moment, the client, as we can see here, when it says use create auction, will also one moment. No, I will show you this later. Sorry. So next, let's go at the function that handles the activation, which is very simple actually. It's a step. Let's say it's a security step, like in order to be sure that the user actually wants to start that auction, and so it needs to provide. So the user needs to provide the auction ID and the ID of the NFT that is being put to auction in order to be sure that this is a method we use for now. So the user is sure that they are bidding the correct NFT. And so what we do is we check if the user is authenticated, we fetch the auction, and if it's not found, then we return an error. And if it's found, we check for all the conditions to be satisfied, for the token to be actually owned by the current user. And then what we do, we basically update the current auction details, and we set the status to active. Sadly, there is no spread operator, so this is how we did it here. And then we return a successful response in case of success. And so yeah, this is the whole closing the auction and the closing the auction, creating the auction and activating it. And next, let's get back to the bidding. So what happens when a user places a bid? A method gets called, and and these things should happen. Ledger canister should transfer ICP tokens from Alice to the backend, and the ledger canister transfers ICP from the backend to the former highest bidder. So we will look at bid here. Here's the function for bidding, and the bid payload that we provide to this function is made by an amount, which is the amount of ICP we want to pay, and the auction ID, which is the auction we are bidding for. First, as always, we check if the user is authenticated. We calculate the caller account by using a function. And then the caller account will be useful in order to transfer the amount of ICPs inside with the ledger canister. Then we actually check if the auction exists, check if I am allowed to place a bid. Then we retrieve a list of all these bids and see if the bid is valid. We check for the expiration of the actual auction. And we also, so here we are calling the ledger canister. We are calling the account balance function of the ledger canister with the caller account in order to get the caller's balance, so we can check it if it's actually correct, and if it's not, it throws an error. if it is correct, then, like we said, we return the tokens to the previous highest bidder. And we calculate the highest bidder's account, and we again call the ledger transfer function to transfer the funds from the backend to to the previous highest bidder's account. If we encounter an error, we return a transfer error, and if it's okay, we continue, and we create an object. We create the bid object, and we update the bid map. And now we're updating the auction map. So here we update the bid map, here we update the auction map with all the required data. And here we update the user map. Yeah, so we update all three maps that we use. And we increment the bid ID, and we return the bid object after a successful response. As I want to check one thing here. I think I'm looking at the... Exactly. So here you can see that in the front end, we are, so before, this font is so big, I am not used to being so big. So, okay. So after placing a successful bid, we also, so we call the ledger, since we are authenticated as the user on the front end, we call the transfer function of the ledger also as the current user. So we actually transfer the money to the backend canister. Then we are going to the auction closing. So what happens when Bob closes the auction? The NFT canister transfers the NFT from the backend, the escrow, to Alice, to the highest bidder, and the ledger canister transfers the ICP from the escrow to the highest, to the seller. There's only one seller, as far as I know. So let's go to the close auction function. And as we can see, it only takes one parameter, which is the auction ID, which is actually a natural number. And as usual, we check if the caller is authenticated. We check if the auction exists, and if, of course, the caller is the owner. If the auction, we check if the auction is expired. So exactly, we are checking for the expiration, and we're also fetching some bids, the auction bids. And why are we checking for expiration? Because the conditions for the bid to be, so the user can only close a bid when the buy now price has been reached, or when the on where it expired. So assuming there is no highest bid, it can only close it. They can only close it when it expires. So here, this is what we're checking for here, basically. And if it hasn't expired yet, then the user is not allowed to close the bid. If it did, though, we just update the auction map. We update the status, basically. Like before, there's no spread operator. So all of this is just for this. And we return a successful message. In case there is a highest bid, we are also checking for the buy now price. And if the conditions are met, we get the token amount, we calculate the token amount, and we transfer the, like I said here, we transfer the NFT from the backend to the highest bidder by performing this call. And here we're doing this part here, which is transferring the ICPs. And then again, we're updating the auction map, and we're setting the status to closed. And we are returning a successful message. Again, a lot of stuff is maybe not as elegant, but yeah, we've just like started with Motoko, so it's still we still need to get used to a few things. So if the code looks ugly in some bits, you forgive us, please.
I don't think it does.
Oh, thank you. And so next we have the frontend canister. I've shown you a little bit of it, like how do we do some calls, etc. But now let's focus a bit on how the user is authenticating and how the actors are being regenerated, and how do we call the remote canisters. We created this class here that we actually instantiate. Yeah? We just use a single instance of this class through the entire application. And it uses the Dfinity auth client library. And what it does, it's basically if the user is not authenticated, it's using the default actors. And if the user is authenticated, it is regenerating the actors with the identity of the authenticated user. The login function will call the login function from the auth client, which will actually open the internet identity UI so that the user can go through the whole login procedure, and the logout function will log out the client and reset the actors to the default ones. So these are the default actors that we are importing here. And as you can see, by default, they're set to those. And when calling logout, they're set to the default ones. And then so everything here, since this is a React application and we want things to be reactive, we wrapped it up in a hook, and we are using actually a Redux context. We're actually using a Redux managed state to see if the user is authenticated and if everything is initialized. So whenever we want to perform some remote calls to the canisters in our applications, we will always go through the use auth hook, basically. Even if we're authenticated, even if we're not, this is what will return us the let's say the most updated, like the actor that is interesting at the moment. So if we're unauthenticated, it will return the default actor, and if you're authenticated, it will return the authenticated actor. And so yeah, basically what we do is we're just dispatching a few things around. I don't want to go too much into detail here, since this is mostly React and less Dfinity and Internet Computer.
Still useful because we aren't making calls to the IC, but I guess in the shortness of time, you
yeah, exactly. I know I would love to, and I think in the tutorial I am going deeper. Nice. But yeah, since we only have a few minutes, let's continue. But basically, yeah, what we're returning, the important thing is what we're returning. We're returning the login function, we're returning the logout function, we're returning the user authenticated flag, initialized, the ID of the currently logged in user that can also be undefined in case we are not logged in, and the backend actor, the NFT actor, and the ledger actor. And like shown before, we have some other hooks. For instance, if we want to retrieve all the auctions, I didn't show you before, but we have the get auction list query defined here that will basically return an array of all the with all the existing auctions. We do not do pagination yet, even though that is definitely a thing to consider in the future. How do we call this? We are using this hook. We are calling the dispatch because we're dispatching it to a Redux, dispatching it to the Redux state. Here we are using the userout hook to retrieve the backend actor. We're using a flag for loading. We are returning a callback and the loading flag. And what we do here inside the callback is we call, it's as simple as just calling backend.getAuctionList, and this function will get called, and these auctions will be returned here. And we've implemented a few functions that we've named mediators. So since a few types, since when Definitive built, it generates some types, but they are not very comfortable to work, not always very comfortable to work with in the front end. So we just defined some functions that translate from one type to another. And now we're dispatching these and dispatching a few other things. And yeah, this is how the front end actually works. And it does the same with the backend. It does the same with the ledger. Here we're not calling the ledger. We are calling the NF, not in this one, in this one. So for instance, here we were calling the ledger, as I was showing before, we're calling the ledger. And here we are calling the transfer method from the ledger canister. So, and we can also just call NFT in case we will need to perform calls to the NFT later. So next, let's go to the how to actually run this whole thing. We will run the local DFX instance. We will go through the DFX configuration, and we'll show you the whole deployment procedure. There should be time. I just need to move the Zoom thing because it's in the middle. Let's have a look at the DFX first. So in the DFX, we are using the local network. We're using 0.9.3 version for now, even though I think I've updated it in the most recent one, but whatever. Here we are defining the canisters. So as you can see, we have the ledger canister, and we are using the WASM that we've built from the official repository, and and the canister interface that has been built from there as well. It is actually right here, and so this is the whole root directory, and it's right here in the root directory. This is the private DID, and this is the public DID. The private DID will be useful in a bit. I'll show you. And here we are declaring the NFT, the backend, the front end. The internet identity is not part of it. It's being deployed bit differently. So how do we actually deploy the stuff? First of all, we need to start the instance with dfx start. I will also add the clean flag, so everything starts new. And then, so first of all, we make the identity. This whole process is described in the in the tutorial. So I really like would like you to check that out if you are interested in how to do it. And with here, I'm just going through some instructions that I've added. It's a bit big for me. So make identity will basically call this script deploy identity, and the deploy identity will cd out of this directory and just go into the internet identity directory that has been fetched previously from GitHub. There is also a command to fetch it, and that is documented in the tutorial. And it's deploying the internet identity to the current GFX instance. Now, what we need to do is deploy the ledger. But first, we need to change this from public to private, because in order to deploy the ledger, and to make some initial configurations, we need to have the private interface. So let's call make ledger. Make ledger will call the deploy ledger script. And it does a few things. So we're actually using a Minter account and a ledger account, and we're calling, we're deploying the ledger with those accounts. This is better documented in the tutorial. Again, not going to go too much into detail on this, but basically we will have one account that will have some credits in the beginning.
But that's also good. Like, you're showing how everything works now together overall, and then you can, anyone who's interested to replicate this or do something similar, then they can check out a tutorial which is more detailed.
Yes. So it has been deployed successfully, and now we just deploy everything. So like the backend, the NFT, and the frontend. So actually, no. First, we need to run the create because we actually need the backend principle to be defined first. So we need to create the canister. So here you can see that all the principles are being created. And then we can finally deploy. And as we can see, this is running the FX build to build everything. This is installing the backend. This is installing the NFT, the front end. And like I said before, right after deployment, we call the NFT, the init function of the NFT canister, and we provide the backend as the owner of the NFT canister. And there has been an error actually.
And we have about 5 minutes to wrap up, just so you know more or less how to. No pressure.
Yeah, pressure. Maybe it's a yarn thing. I hope so. Please let it be yarn. Oh, there's a different version of DFX. Apparently, they didn't change it. I have a different version of DFX actually, so I just should update this one. 0.10. Oops. Here we go. Let's
People from the audience, please pray to the demo gods so Marius can fix this quickly. Demo gods have been kind to us lately, so I don't see a reason why they wouldn't be today.
I hope so. They're not so kind, apparently, for some reason. Let's be super fast and run it again, maybe. And I know let's change the effects. So yeah, again, make identity. This is a perfect way of rehearsing what we just make identity, and then okay. Make ledger. Hoping that it's still private. Yes. Okay. Now that I've also remembered, this needs to go back to public. And again, another error. Okay.
I think it's the same, no? It's the 255 error.
Payload too large.
Maybe you're trying to upload a lot of things and the message size cannot be more than 2 megabytes.
Probably.
But actually, you're barely above the limit, if you can see. So message byte size is 21 something and you're allowed 20.9 something.
This is weird. Yeah. But yeah, I think this will take some more time then to fix a few things are not working.
In the last few minutes, can you point us to the tutorial and show where
yes,
it is?
Sure.
How it looks?
Exactly. So next thing, the tutorial is at Kryha Academy. It should work with the currently deployed version. Now I made some modification probably, and so that's why it's not working. So if you go to Kryha.academy, let's just go this one. Kryha.academy. And here we go. We have all the articles and lessons that will walk you through the actual deployment of the application. So
that's awesome.
We have different sections. We start from what are we building, how to set things up, like the initial setup. We talk about the external canisters first, the ledger and the identity canisters. We talk about how to deploy the NFT canisters and what I explained to you today about the NFT canisters and even more, and the backend canister as well, and the frontend canister. So yeah, go have a look, have some fun. Let us know what you think about it, and yeah, I'm really sad that it had some deployment issues in the end, but it does work, I assure you.
Yeah, that's okay. These things happen, and it is what it is. Yeah, I think this is the perfect time to wrap it up, as I don't see any more questions, and we are right on time. So thank you very much, Marius, for this great demonstration and going over the code. I think now I have something that I can point people to, a video that I can point people to if they are asking questions about NFTs or the ledger, because it's you pretty much went through every step that someone needs to know about creating NFTs. Or
yeah, we had to go through a lot of forums and stuff. Sorry to interrupt you, but yeah, that was
no.
Good. I can see how developers can feel about it, because yeah, I had to go through different forums and questions and things, and a lot of explorations went into it, and not just me, but everyone in our team. And yeah, I think this can be really a very useful tool for a person to find, for a developer to find good and like a good way to build NFTs without having to look everywhere.
100%, 100%. So yeah, thanks again, Marius, for today's workshop, and thank you everyone who joined today. But also thanks everyone who have been following the whole Supernova workshop series. It's been a lot of fun to talk to all these talented developers and see what they're building and how they're working. So it's been an honor, fun, and let's hope that something like this continues in the future and it takes different forms later. So yeah. Thanks a lot, guys, and good luck with Supernova. All the developers, just the last few hours. Hurry up, and yeah, good luck with the submissions. Cheers, everyone.
Thank you very much.
Bye.
Bye, guys.